Hello everyone, this video is about a very basic topic, that is derivative. Heading towards the definition, or we can say the formal definition of the derivative, that is an expression representing the rate of change of a function with respect to an independent variable. This is just the formal definition of the derivative, but the core word, or we can say the main part of the definition, is the average rate of change or the rate of change. So what is a rate of change? We all know that rate of change is when talking about the 2 points, and the 2 points that of a function. First of all, we're talking about a rate of change. We have to know that there is a function f of x. Usually f of x is taken as a function that is equal to y, where y is the dependent variable and x is independent variable. So the average rate of change, or the rate of change of 2 points of a function over an interval, right? I have to draw a graph in order to, we can say there are 2 points on a straight line. There is a point A and the next point is B. The image of A is f of A here. Let's say this is f of A, and the image of B is f of B here. So now there are 2 points. First point is A and f of A, and the second point is B and f of B. First point and the second point. So we can understand the definition of the rate of change because we all familiar with the slope of the secant line. By definition of the slope, we know that the formula y2 minus y1 over x2 minus x1. Here talking about the 2 points here. So we can write f of b minus f of a over b minus a. So the average rate of change of the function f of x over an interval between 2 points, so these are 2 points as I already mentioned, this a f of a and b f of b, is the slope of the secant line. As the definition of the secant line I just wrote by defining the 2 points on a graph of a straight line. So because the rate of change can be small as we take the 2 points, the distance between 2 points can be made as small. So if b moving towards a, so we can write it as limit b approaches to a, f of b minus f of a over b minus a. So basically this is the mathematical form of the derivative. So as I have already mentioned, this is the core word, this is the very important word, and by defining the derivative or by writing the rate of change definition into the mathematical form, we just extract the mathematical expression of the derivative. General way of writing the mathematical form of derivative is limit a change in x approaches to 0, function where x plus delta x, the value of the function at this point, minus divided by delta x. Because why delta x approaches to 0 here? Because in general we take x as I have already mentioned that x is independent and y is dependent. So by keeping in mind this, we can write the general way the derivative in mathematical form. So if we want to find the derivative at a specific point, that we can say the derivative of a function at a, fx is equal to a, and we can find the derivative at a. So limit x approaches to a, f of x minus f of a over x minus a, and we can write it as y at a. So this is the particular way of finding the derivative at a specific point, and this is the change in y with respect to x. No, with respect to x, yeah. And also written as y dash, y prime or y dash it is. So this is the general or the more common way of writing the derivative in this way. We've just now talking about how we can solve or how we can find the derivative of a function, because there are a variety of functions that we are dealing with, polynomial functions, trigonometric functions, implicit functions, hyperbolic functions, inverse functions, and so on. So there are basically two ways to find the derivative of any function. First is the first way is by principle, by the definition or by first principle. So first way is by definition, by using the definition or by first principle. And the second way is by applying theorems. So there are a number of theorems that we can apply. So hopefully we will talk about these two ways of finding the derivative in the next video. So stay tuned. Goodbye.